Alright, hi guys, we're gonna work on a problem today. We're gonna do a rational function problem. Since we have a test coming up and a lot of you guys, it doesn't really look like to me that you guys picked this material up as well or as quickly as I thought, so we're just gonna reiterate a little bit. And I'm gonna do a problem that will show you what you should have to do on the test or be able to do. Alright, so I'm gonna first so if you open up the book and you go to page 26, or you go to page 541, we're going to do number 26, which says the integral of, and then for the numerator, it is x squared plus x plus 1, x squared plus 1 squared. Alright, over x squared plus 1 squared dx. Okay, so this is the problem we're going to do today. Alright. Alright, let me take that and then go to paint. Alright, so we're going to work on this right now. So we first see it's rational, and then we see can we do long division? No, we can't, because the numerator is smaller than the denominator. So we know we have to do partial fraction decomposition. And alright, so because we know that, we know we have to break it up into, we'll have x squared plus x plus 1 is equal to 1 over, and then a x squared plus 1 squared, and then this is one of our terms here is it's to a power 2, the second power, so we write it until we get to 1 and then we stop. So if it was 6, we'd go 5, 4, 3, but because it's 2, we go to 1 and then we stop here. So now we have to find the coefficients a and b. I'll write this nicer. This is a right here. So here's what we do to find a. Multiply by a common denominator. A doesn't really need to be multiplied by anything because it's over x squared plus 1. So So we're just going to have a b. It's only missing a factor of x squared plus 1, so we just multiply by 1. And then now we solve. So one way to solve is to use equate coefficients. Equate coefficients. So to use equate coefficients, we first look at, we want to factor everything by x. So if we factor this will, if we factor with respect to x squared, we'll just have b. If we factor with respect to x, we'll have nothing, 0. And if we factor with respect to the constants, we'll have b, a plus b. So x squared is b. We look at x squared over here. It's just 1 because it's just x squared. So that's how we know that that's going to be the value. So we can say x squared, or b is equal to 1. Ignore that. Okay, we know b is 1. Now let's find the rest. So we know x to the 0, a is equal to 1 because so a plus b is equal to 1 because we just have a constant here. So we can say a plus b is equal to 1. Put 1 in, so you have a, substitute b for 1 for b, and you get this. That means a is equal to 0. So we have a and b now. Alright. Okay, so a is 0, so for here we're going to have nothing, and then b is 1, so we can rewrite this as integral of 1 over x squared plus 1 dx. So this is a formula you should have seen before. It's tangent, so tangent inverse actually. 1 over a tangent inverse x over a plus c. So our a is 1 right here. Our x is right there. So this is just plain old tangent inverse x plus c. And this is a indefinite integral since there's no bounds. Alright, that's all I have for you guys. Have a day. Alright, I have one more we're gonna try. So this one will be on the test. This is number 42. So it goes integral, it's not good. Alright. You have the integral of tan inverse x squared dx. So tan inverse x over x squared dx. Alright, solve it. Okay. We first see the integral of tangent inverse x. We know that the integral for tangent inverse x is this. This is equal to 1 over 1 plus x squared plus c. Okay, so if we make, let's just say u is equal to x. Alright, what would that be? That substitution, it just wouldn't, you can't substitute that because you might be able to get tangent inverse x, but you still have x to negative 2, and there's no substitution that would work. So let's try to rewrite it. We can rewrite this as tan inverse x times x to the negative second power dx. And then this would be integration by parts. So when we do integration by parts, which is, the formula for that is uv minus integral v du. We ask ourselves, what's u? So to determine u, we use Lyautey. And Lyautey is logarithmic, inverse, algebraic, trig, and then e is exponential. So this could be ln, this could be y equals just say something like 5x to the negative 1. Algebraic is like y equals like a polynomial. Trig is like sine, and then exponential is like b to the x. Alright, so whichever one you see first in going in this order, that's your u. So we have tangent inverse x and x to the negative 2. Neither of them are logarithmic. We have tan inverse x is an inverse, so we know u will be tan inverse x now. So du is equal to dx 1 plus x squared. Alright, the next thing we have to do is find v. So v, we set it equal to what we have here, x to the negative 2 dx. So we get v is equal to, this is just power rule for integration, so add 1, we get x to the negative 1, and then negative 2 plus 1, we just have negative. Alright, let me move down. So we put in u. We already know what u is. U is just tan inverse x, so we're going to have tangent inverse x times v, which is times x to the negative second, minus integral v du, which is one mistake. Put a negative here and then make this negative 1, because that's what v is. We're just substituting for v, and then minus integral of v du. So this negative and this negative will cancel, give you positive. You'll just have x to the negative 1, that's the same thing as 1 over x. And then du. Du is equal to, so we have uv minus v du, 1 over 1 plus, du is equal to dx over 1 plus x squared. So then we have dx, and then this is over 1 plus x squared. So the first part right here, nothing changes, that stays the same. So for that part we have tangent inverse x with and then plus integral of x plus x cubed. So 1 over x plus x cubed. I'm going to keep it written like this because look at it. Can you do a substitution? We can make u equal to 1 plus x squared. No, we can't, but it looks like our best available option is to do partial fraction decomposition. So that's what we're going to try. Alright. So I'm going to continue the space. I'll do it here. So I'm going to write this one separate. I'm going to switch color to blue. I'm going to write it up top. Alright, so we're over here now. I'm just doing this one. Alright, so we can rewrite this as 1 is equal to a over x plus b over 1 plus x squared. So then multiply for a common denominator and you get a times 1 plus x squared plus bx. And then we have x squared a plus x b plus x to the 0 a is equal to 1. So if we look at x to the 0, we know a is equal to 1. And then b, how can we solve for b? Let's plug 0 in. So we're going to do substitution. So when we do substitution, we put 0 in for x. That's going to give us, that's going to get rid of b, which we want to keep. So let's plug in 1 instead. So plug in x equals 1. We get a plus b plus a is equal to 1. We know a is equal to 1, so we're going to get b is equal to negative 1. Because you have 2 plus b is equal to 1. So b is negative 1. So now, what we have to do now is, let me back up. Alright, there we go. So then, this u part, that's the same. Nothing changes there. But the part that changes is this integral is going to become 1 over a, which will just be 1 plus, and then we have b, which is negative 1. So this should be minus, and then 1 over 1 plus x squared, and then this whole thing dx. So when you evaluate this, you get negative tangent inverse x over x, and then the integral of 1, that's a constant, that's just x, and then the integral of negative 1 over 1 plus x squared, that's just negative tangent inverse x plus c. Pretty straightforward, pretty simple. And that's all I have for you for this problem. Does anyone have anything they'd like me to go over? Well, hopefully you guys are ready. Take it easy. Have a good day. Class dismissed. I'm gonna draw a car just because I have nothing to do and I like to draw cars. It's so cool to just be able to draw a cool car. This car is gonna be a sleeper car. If you can draw like really well in Microsoft Paint, I think you're D1 bound. Takes a lot of finesse to be able to draw in Microsoft Paint and do it well. Or so it seems. I have a tough time getting the concavity inflection sometimes, but mastering that's like the key to drawing really well. I'm not gonna lie, this car is, it definitely is like not that great, but it turned out better than I thought. Like, I could have probably drawn a better car if I tried a little harder. Look at her. Look at that car. So nice. I really wish I could go to school this semester. I wasn't able to go because I didn't want to. I wasn't sure if I wanted to get vaccinated, and it was too late. And then I had to pay all this money up front, and I wanted to see a counselor first because I'm pretty sure there should have been like a refund because I didn't. Tried to withdraw, but Canvas was down, and I tried to talk to a counselor about that too, but I just never. I talked to them online, and they didn't really like help me out. It was 12 o'clock, and yeah, the deadline to withdraw is midnight. And I was on it, but Canvas glitched out, and it said it's unavailable, and I wasn't able to drop. Alright guys, I'm gonna end the stream. Have a good day. I'm also gonna make this public because I don't really see why not. Have a good day, cuties.